Hello, I'm Silver, and in this presentation, I'm going to talk about the importance and use of IDEs in software engineering and the software development process. IDEs are integrated development environments that support developers to program efficiently and increase productivity and expedite the development process by providing useful tools to the developer. An IDE gives a user a central interface to manage their project and project files and allows for easier integration of different software engineering practices all in one place. Software engineering is about more than just programming. It's also about maintaining the software after it's been built, testing and debugging the software, and also designing and developing the software while working to ensure high quality software is produced. IDEs support this goal of software engineering by providing the features they do. IDEs provide a lot of functionality and uses for software developers and allow developers to start coding new projects as soon as they download the IDE. It centralizes development tools into one development environment and manages the organization of workflow and often has support for version control systems like Git. While there are many different IDEs with different specialties for different types of programming or programming languages, the majority of IDEs include the same set of universal tools that aid in all software development: code editing automation, syntax highlighting, intelligent code completion, support for refactoring, build automation, compilation, and testing and debugging are the main functionalities provided by IDEs that support the developers. An IDE often has knowledge of a large set of programming languages and their rules, and because of that, it has features for writing code automatically. This includes generating code stubs like class definitions or method stubs, or completing code based on suggestions based on context or patterns in the code. Syntax highlighting is helpful in displaying different types of terms in the source code in different colors. This makes finding issues in the code easier, and it is easier to see issues with enclosed brackets or parentheses with this feature. However, this syntax highlighting is often present in some text editors too and isn't always specific to just IDEs. Another valuable tool provided by most IDEs is the support for refactoring. Refactoring can often be a big part of software engineering because it can improve code by making it more efficient when you fix dependencies or complexities, and refactoring might be necessary when in the maintenance phase of a software development cycle and you need to make the code easier to reuse or maintain, or make the code more efficient and readable for future users. For these reasons, IDEs to an extent provide the ability to refactor code quickly. One example of an IDE with a lot of refactoring support is IntelliJ, and the IntelliJ IDE includes refactoring options such as renaming a term, encapsulating fields, moving static members, and extracting interfaces, delegates, or superclasses. When you choose one of these options, the IDE automatically selects and refactors all of this for you, so no searching and changing each individual term or selection is necessary. The table on this slide indicates some of IntelliJ's most popular refactoring features. Oftentimes, IDEs have an option to compile and run the code at the click of a button. If it's not possible to do it with just one click, the IDE will often have configuration options and a configuration management tool to help developers easily make or change the run or build configurations. Testing and debugging is also made easier by IDEs. Unit tests are often supported, and these can be used before even integrating with the rest of the code. These can be isolated tests for whatever code is currently being developed. When debugging in an IDE, visuals are usually provided to show where you are in the code. Feedback is also given by tests, and being able to step through the code at each line and step into specific lines while debugging is one of the most useful aspects of an IDE support for debugging. Additionally, having a code analyzer to evaluate your code for bugs or errors speeds up the debugging and testing process. Simple text editors lack this, and having to recompile or rerun your code just to discover minor syntax errors can be a pain and also take up a lot of time. After discussing the main tools provided by IDEs, can you think of a time when you used an IDE and the tools it provided significantly improved the quality of your code or your productivity as a developer? Does a specific tool come to mind that you appreciated most from an IDE, or is there an IDE you gravitate towards the most, and why was that? In the next few slides, I'll be going more into depth about some differences or specialties of some IDEs, and as I discuss them, I encourage you to brainstorm ways these IDEs would be helpful in future programming projects you might endeavor. As I introduced in the last slide, there are different types of IDEs that support different developer needs. There are both IDEs that support multiple languages as well as IDEs customized for specific types of applications. Some multi-level IDEs include Eclipse, IntelliJ, VS Code, and NetBeans. Eclipse supports C, C++, Python, Java, and other languages. There are also IDEs like Android Studio or Titanium Mobile that make developing mobile applications easier and cater to that kind of software development. Some features of Android Studio useful for mobile development include the ability to create layouts for Android development by using an interactive tool rather than just writing out the raw XML code. You are also able to view your changes to the layout as you change it with this layout editor. It also has a built-in emulator which aids in testing and simulates various features of mobile devices. This makes it easier if you need to test on different types of devices and don't want to buy the actual device. I'll now talk a little bit about a few different IDEs and how they cater to different types of development. Cloud IDEs are a type of IDE that help developers who have large projects that would take up a lot of memory and resources on a local machine. Instead, the heavy lifting can be done on a remote machine or server, and no one has to deal with issues with the code only working on certain machines or configuration errors due to local machine differences. It makes it so the code is independent of differing local development environments and frees up local machine resources. Some IDEs that cater towards HTML application development include Dreamweaver, Homesite, and FrontPage. Dreamweaver has features to aid users in developing websites in HTML and CSS. It is a visual editor as well as a code editor that allows drag and drop functionality as well as responsive resizing to fit different sized screens. It has features that help web developers manage the files for a website and a publishing tool to help with the file management, both on your own web server and locally. Komodo Editor is another IDE specifically for HTML, and one of its main benefits is the ability to view live previews while editing. PyCharm is one of the most popular Python IDEs. It has an intelligent code editor that helps the user write high-quality code. It supports quick refactoring similar to other IDEs and supports many popular web frameworks like Django. PyCharm is a specifically useful IDE for data science or machine learning projects because of its support for libraries like Matplotlib and NumPy that are used primarily for these types of programs. A widely used and popular IDE is VS Code, which supports many different languages, especially because of its comprehensive collection of extensions and plugins that can be downloaded for different reasons. You can download an extension for almost any language that will then prompt code editing, syntax highlighting, and code completion for that specific language. There are also extensions for containerization tools like Docker and many other extensions that a software engineer would find useful. It is a well-appreciated IDE because it can be used for so many different types of projects and programming languages. IDEs arguably do have some disadvantages, such as them having a learning curve for people who are just starting to use the tool. Additionally, an IDE that's too sophisticated might confuse and slow down beginners at programming. However, the benefits arguably outweigh the disadvantages. Learning an IDE will benefit software engineers in the long run, as opposed to having to use a simple text editor and miss simple syntax errors and small issues with the code. IDEs speed up a lot of the software development process and overall benefit developers in the software engineering process. Software engineering is more than just programming, once again, and IDEs address that by providing tools and integrated environments to support engineers' needs in developing and maintaining quality code. I hope this presentation provided some insight on how IDEs can be useful in software engineering and also encouraged some of you to try out different IDEs for your coding projects. Thank you for listening.